Welcome this morning. My name is Crystal Rose. For those of you who have not done one of our virtual programs and have not met me before, I'm the manager of digital learning here at Mystic Seaport Museum, and we are excited to be providing as many free public programs as we can. And today we have a real treat lined up for you. We have Nicholas Alley, who is on the staff at Mystic Seaport Museum, and he is currently our Yachts on Exhibit coordinator, so he can tell you a little bit about that and about his life as Captain of the Brilliant, which I'm sure many of you out there, former Captain of the Brilliant, which I'm sure many of you out there are familiar with. So Nicholas is going to be talking about charts and navigation today, and the way that we do these programs, just for anyone who's just joining us for the first time, is that instead of everyone's is muted, and if you have a question or a comment, anything you'd like to ask Nicholas, if you could write it in the chat box for us, that would be great. If you're not familiar with Zoom, if you roll your mouse across your screen, the bottom of your screen, you should see a menu bar, and one of the options there is chat. So you can click open that chat box and you can type in questions. And what I'm going to be doing is I'm going to monitor the chat while Nicholas is speaking and showing his charts and his tools. And if you, as we go along, I'll check the questions and I will interrupt Nicholas every so often and ask questions, or some questions I might save until the end. And it looks like today Nicholas's program is quickly splitting into two parts. So it looks like we're probably going to do part 2 of this program, maybe hopefully next Tuesday afternoon. So make sure that you're on our e-blast list. And I'm happy to add anyone who is not on that program or not on our email list. I'll add my email address right here in the chat box. And yeah, this I had a good question. This is being recorded so that you can view it later. And that will be available either by emailing me. I can send you a temporary link, or this recording will be available on our YouTube channel in the coming weeks. So without any more delay, I am going to unmute Nicholas and turn the program over to him, and I'm just here in the background, so if we have any tech issues, we'll definitely work on that. Hi Nicholas, how you doing?
Hi Crystal, thank you so much for such a wonderful introduction, and thank you for doing all of this hard work to allow us to do this. This is a new thing for me. I'm pretty excited about it and scared too, so you'll have to bear with me. So as Crystal said, I was captain of Schooner Brilliant and have been a boat captain for most of my life, and as such have been playing with charts and navigation equipment for most of that time, and it's a necessary thing for us for a wide variety of reasons, and we're going to go into some of those reasons. Our goal for today is we're going to sit down and we're going to look at a variety of charts and maps. We're going to have an introduction to what we use them for, the symbols that are on the charts, and then the second part will be we'll look at some of the navigational tools that we use the charts to figure out where we are and where we're going. This is an introduction course, and as Crystal said, that we're going to extend this. We realize that there's a lot of information here, and I like to talk, and since I like to talk, they're going to let me talk another day. So again, what I'll do is I'll introduce a lot of things today, and then in the future we can look at getting into more detailed use of the charts, navigation tools, and so on and so forth. So what I wanted to do first is just sort of show you a bunch of different types of charts, and we'll look at all those right now, and then we'll settle into navigational charts that are produced by the National Oceanographic and Atmospheric Administration. And the reason I say that is if you go online and Google them, you can find a lot of these charts online. As a matter of fact, we'll be using one of our charts online for Fisher's Island Sound later in the program. So right here, if I look at my screen, I'm going to ask, we're going to switch screens here. You can see this is a race rock light, and for some of you that may not mean anything, and for others it might be your home lighthouse. This is the lighthouse that marks the entrance to the race where Long Island Sound meets the North Atlantic, And the reason I have this up is this is our first one of our charts that we're going to be looking at. I'm going to go in, some of these might seem a little silly to you, and I'm a silly guy, so maybe so. Here is a map or chart, and one of my first questions is, does anybody know the difference between a map and a chart? Now you can see in this one here, we have Mystic and the Mystic River, and we have some advertisements. Notice that a lot of the detail is on the shore and not on the river. There's no detail about how deep the water is or so on and so forth. I would probably call this a map. So this is a map of Mystic, and this one is designed so you know where to eat and where to visit our many vendors. This is a great little tourist map for coming to town. And
yeah, Nicholas, I just wanted to say we did have some feedback in the chat. Chip was saying a map is land and a chart is sea.
Exactly. Yes, perfect. And very important right here, I hope you can see that, that's my house. So, you know, if you ever come to Mystic, let me know and you come on by. All right. We're going to go ahead and get rid of this map. Here's another map, and I've gone through my collection. And so this one here shows the town of Boston, Massachusetts, my hometown. And in 2017, they had a tall ship parade. And they gave us these maps so that we could tell where we wanted us to run. So here you can see the white is the land. And these arrows represent the course that they wanted us to move the boats, because of course, if everybody went everywhere they thought they would, it would be quite a higgledy-piggledy mess. So this is kind of interesting. I would call this a map because the details are on the land, not so much the water. If I turn this over, this is the actual parade route, starting out here off of Nahat, sailing all in. They were supposed to gather in these areas and so on and so forth. So obviously the focus on this map is the parade coming into Boston for Tall Ship 17. This here is a map, and this is a map of Newport, Rhode Island. And of course it does have most of the detail on the shore. It's got streets, it's got all these numbers, and all these numbers correspond with different highlights of places they'd like you to visit while you're in the town of Newport. This right here is kind of interesting, and you will find this on most maps and charts. It's a key, and this will give you information from the different symbols and what they mean. And you're probably familiar with that. And then this right here is what we call a compass rose, and that will tell us direction on a chart. In this particular case, as with most charts and maps, this right here is north, and north is, on modern charts, is always at the top of the chart or the map. And here's a much more detailed section of downtown Newport. So if you wanted to go sailing, you could come down to some of these piers and get a boat to take you out sailing. And then, of course, there's many fine restaurants. And the reason I like Newport is it is a very big and super sailing town, okay? I don't know if you can see this very well. This right here is a nautical chart. And this is another rendition of the chart that we're going to be looking more closely at later. And you can see that it's got a lot more information on the land, on the water, excuse me. You can see Mason's Island, but you don't see roads, but you can see out in the water, you can see the buoys and the charts and the water and the depth and so on and so forth. And we'll be going into much more detail in a little bit. This map is a place map for one of the local yacht clubs. So I kind of like that because it's nice and small. This here is an interesting one, or at least interesting to me. Believe it or not, this is a chart of the Mystic River. And this focus here is on the depth of, very particularly, the channel or the roadway that leads into the city, or excuse me, into the town. Right here is Noank Light. This is Morgan Point, for those of you who know this area. And this is the channel running right down here. Now, inside that channel, you can see these are the buoys, okay? The red ones on the right, red right returning, so we're returning, so you keep the reds there. And these buoys mark where the channel is. Does anybody know what all of these lines might be? They're really small, but they contain information. I'll give a second to see if anybody comes up with that. Okay.
Let's see. I don't see anything in the chat box so far.
Yeah,
maybe
you can't see them very well, But
That's
this,
okay. We do have some
go.
guesses or some thoughts, depth numbers and soundings.
Exactly. Depth numbers and soundings. Whoever said that kind of knows a little bit about boating. These are indeed soundings, which is what we call depth when we do them on boats in the maritime world. This is a sonar outlay showing the depth of the channel and also outside the channel a little bit going down Mystic River. They did a survey for the entire river a few years back, and this is a copy of that chart. So it goes on and on. So that's really handy for me because Brilliant needs 9 feet of water to float in. And if I get into water that's a little bit shallower than that, the boat will stop. Sometimes gently and lovingly, and sometimes with a hard crash if we get into the rocks. Those we try not to do. Okay. This chart here is a hurricane plotting chart. Now, you've probably seen these on television as well, but if you're a mariner, you don't have necessarily television. So as you're listening to the radio, you can get a position of a tropical storm or a hurricane, and you can come down here and using the latitude and longitude scale, put the position every day of where the hurricane or the low pressure or the depression or whatever you want to call it, the storm is. And we've all seen this on television when then the next day it shows it here and here. And sometimes they come into the Caribbean and the Greater Antilles, and sometimes they very rarely they'll hit down here. But then of course we're so used to seeing them either go up the East Coast or into the Gulf of Mexico. So this is a hurricane plotting chart or map. This one here is interesting. This is what's known as a pilot chart. And this is a booklet, and this covers a number of different areas. I have the Atlantic, and there are 12 of them, 12 of these little maps in here. And that's because in June, in the North Atlantic, this is what you would expect the winds to be like. This is an average. So we've got the blue, which talks about the wind direction. And as you can see, down in the tropics, the wind is predominantly from an easterly direction, blowing from the east to the west. Okay. And then it's up in here, it starts to get a little wiggly and does a circle. This also drives the water underneath it in that direction. And these are a little tricky to see. I'll come down, but there's some green arrows. And those green arrows right in here in between are the water or the current. And so the current is also moving in that direction. So there's a strong current that flows along like this. If I look up at the East Coast, there's a very famous current that comes in like this. Let me get this refocused. Let's see if that works. There it goes. We got this green current comes up, and then it runs up the East Coast of the United States. Does anybody know what the current that runs up the East Coast past Canada and then ends all the way back up and helps keep the British Isles warm?
We're getting North Atlantic current and Gulf Stream as two answers. A lot of Gulf Stream.
Yeah, that's a Gulf Stream, and and the reason they put that down there is, you still there?
Hold on just a second. It looks like we've accidentally had someone screen share. Oops. Let's see.
I'm sorry, Peter.
That's okay. There we go. Hopefully back to normal. Okay. Sorry about that.
Well, if that's our worst problem of the day, we're doing pretty good. So as a mariner, it's important to know where the wind is coming from, right? If you're sailing especially, you want to know which direction, because if you were going from Florida here to Africa, you'd be going straight in the winds and you'd be fighting the current. It would take you forever to do that. So in the old sailing days, if you were going from Europe over here in Europe, you would go ahead and sail down with the prevailing winds across the Atlantic, and then turn and sail and use the Gulf Stream and the current and the wind directions to get you up into, let's see, we could go here where Crystal's from, or we could go here where I'm from, or we could go all the way up. Now this Gulf Stream is a warm body of water, and as it comes up, it's like a river flowing, so that'll go up. So that's just some of the things that you can find on a pilot chart. And just like the other charts, you'll see it has a key, so it'll tell you what all of these are. And that is particularly helpful if you're doing long distance sailing. underneath that, I have another chart, and this is called a tidal current chart. Now, the other currents we looked at were mostly from the wind. This is Long Island Sound, our home waters. And I'm going to come up a little bit, and you can see these little arrows here, okay? This area here is the race, or the mouth of Long Island Sound, right in here. All the water that goes into Long Island Sound, all this way, has to squeeze through the race. It goes very fast through here. If you look at these arrows will tell you what direction the current is. And then there's a number right after, and that tells you how fast it's going at that particular time. So this
Nicholas,
is 2.4 knots. In the
Nicholas,
race, you can see 3 knots.
Is this the pilot chart?
This is the pilot chart, yes.
Okay, somebody was asking about regional pilot charts, so I think you answered his question by switching to this regional one. Perfect.
Yeah, I'm sorry.
That's okay.
This is a tidal current chart for the area, for this local area. I'm sorry. So so this will tell you, and of course the tide, because these currents are driven by the tide, they go out and come back in twice a day. And so if you time where you're going and how you're going through, you could save yourself a lot of hassles. Because the current can be so strong in here, up to 4 nautical miles an hour, it can create some really rough conditions, especially if the wind is working against the current. So sometimes you'll work very hard to make sure this, so you're not trying to go backwards at 4 knots with a boat that'll only do 6. You'll spend all day just getting through the race. So that's another type of chart that we use regularly, okay? And here, yeah, there it is, the title of that, okay? This right here is a chart of Boston Harbor from 1775 or so. Trying to get that not showing up at all. Not well.
Can you try to focus it with your hand one more time, Nicholas?
There it goes.
There, yeah, that's getting better.
So
and
this
Nicholas,
will give you an idea of what you were looking at back in the old days. Directly below us right here is Boston, the town of Boston, and then Charlestown, and so on and so forth. Notice how small this is. There are a few numbers, and these are all the depths of the water, okay? And you can see right here, this line, for some reason my phone's ringing, that will have to go away, is what they recommended you do if you were coming into Boston from sea, okay? So you come by the islands here, and these are the islands that I grew up with. And the reason I have this chart, you can see there's no aids to navigation, no buoys to show us where we are. So you had to be pretty lucky and pretty good to be able to sail that line and come into Boston, or in this case, they went to Charlestown, which is where the Navy Yard was back in the day. So this is a chart from 1775. And I'm gonna put up now a chart showing a modern navigational chart of the same area. And you can see the difference. You can see that, you know, now there are channels, or the roadways that come in. These are the buoys here. They're very well marked. There's a lighthouse on this point. And as we come into the city, you can see coming along here, more buoys to get you in. And here's the airport. And you can't see the other chart, but this was not here. This is all filled in. And so is this whole area up in here. Boston used to come down and be about this size and come right down this street, Washington Street, Boston Neck. And that was, back in the day, it was great because that way your enemies couldn't get out to the city. But so much of this is landfill here and where I grew up in the South End here. So that's a map, or excuse me, a chart of Boston. Now, since we've gotten into the charts, I'll show you a couple of things that you may or may not have noticed. One is, notice that the navigation stuff stops here. And then they have another chart that runs up in here, and that's the Inner Harbor chart. And one thing that will help you figure out which chart you're looking at is you can see that number right there. That, if you want that information, you need to get chart 13272. This one here is 13270, okay? And we're going to start looking at some of that because we'll start getting into the navigation charts that we use every day. So that's
Hey, Nicholas?
Yeah.
Before you start getting into those charts, we do have a question from John, and he's asking, are tidal current charts available free online through NOAA, like the nautical charts?
I don't know. I've never
I
tried.
can try to dig into that and find out,
Yeah.
Nicholas, and I'll answer that in the chat box. I have a feeling that our friend Shannon McKenzie, who also works at the museum, is on, and she'll know the answer to that. So I will get back to you.
Great, great. So, all right. So now we're going to go ahead and get into charts and information. This right here is what's known as the chart catalog. Okay, and you can see these squares, and they represent a chart. And in the squares, you've got certain numbers, and those will tell you which chart you can get. You can see over the side, they've got a whole list of them. And these are the charts for Long Island Sound to Cape Cod and so on and so forth. And this is a small scale chart that covers a fairly large area from New Brunswick all the way down. And we're going to get into that scale in just a second. But I know you can get these online because I downloaded one yesterday. Which is the one that we're looking forward. And we're more concerned with this area way down in this lower corner, right on down here. And this is what we're going to start to zero in on in the next second or two, okay? I wanted to show you this chart for no other reason than to say, I wish I was in the Virgin Islands. This is the Virgin Islands, and this is a well-loved, well-used charts. And one of the things that that you might be able to see, and the reason I have this chart, is there are markings and navigation aspects on here. And this was a chart, we were doing a trip on another boat that I used to run. And these are, does it? Come on, focus, there you go. And you can see the positions that people have put down as they come in. There's that was at 2203. That was a range using radar.
Can you focus that, here, Nicholas? Yeah.
What's that?
Can you focus that for us?
Yeah, I'm trying to.
There we go.
All right. There we go. And you can see us transiting along. These triangles represent electronic fixes. And then we have the time. Every time you put a position on the chart, you need to put a time, or it's kind of useless. So here we were transiting along the south coast of the Virgin Islands, and we were headed to St. Thomas to start a program. And I just thought that was a nice chart because it reminds me of younger days, and it gives you an idea of how ugly and ugly charts can get when you write on them and spill coffee on them and the whole 9 yards. Okay. All right. Next, we're going to start looking at the navigational charts in a little more detail. I wanted to show you this. This is called nautical chart number 1. And this is a listing of all of the different symbols and things that you will find on the chart. Okay, I'm not going to go into any great detail here. I could spend the entire rest of the program just going over that, but we'll move on with that in just a second, okay? But it is something that's worth looking at, and it is readily available. I don't know if it's online or not. All right, so when we start talking about charts, there are different sizes. These are all charts showing different areas. This one here is a small scale chart covering a large area. And this covers Canada all the way down the Gulf of Maine, right into Long Island Sound, and all the way down to the Antilles or the Caribbean. This chart is what's known as a sailing chart. The goal here is so that if you're sailing from Long Island, Montauk down to the Chesapeake Bay, you can put a line on the chart and know which chart to steer to, okay? There's not a lot of detail in the small areas. The only lights that show up are what we call sea buoys or offshore lighthouses or big lighthouses on the shoreline. And that really just makes it so that you have something to line up just to get you into New York. It's not going to get you through New York, but it'll at least make you find it. And here we even have a buoy that is probably 15 or 20 miles out to sea on the entrances or the approaches to New York Harbor. Okay, so that's that there. Okay. This is the next size down. This is a coastal chart or a general chart, okay? And I'm just going to move this around. And we're getting close to looking at the charts we're going to be using. But this chart is Block Island Sound and approaches. So if you're coming into Block Island Sound, which is this whole body of water that we're kind of scanning over here, there's Block Island. Okay. And there we have the Rhode Island coastline. And this is Point Judith. And that's the mouth there. That's one end of the chart. And then as we come along, we're starting to get into our home waters. This is Watch Hill, which is Rhode Island. Then this becomes Connecticut up in here. And then this right here is Fisher's Island. And Fisher's Island is actually part of New York. And so this is our sailing area, our home waters, so to speak.
Nicholas?
Again, notice there's no detail in Fisher's Island Sound. We want to go for a harbor chart or a much, I always get this confused. A small scale chart covers a large area and a large scale chart covers a small area. So we're going to go for a large scale chart, okay? But before I pull out here, you can see we got the title. We also have the number on here. And I also noticed that the soundings or the depths are marked in feet. Be careful of that because they can use feet, they can use meters, they can use fathoms. Does anybody know what a fathom is? A fathom is an old term and it's 6 feet.
6 feet, yeah, Nicholas. We're getting some good answers in there about 6 feet.
Good. So, so what I'm going to do is this is our
Nicholas. I have to
sound chart.
Nicholas, I just have to share this. Our friend Bob, who is on, says a fathom is the distance we should stay away from each other right now. That's fantastic.
Oh, that would be so cool. We should go around the seaport and trying to say, well, we're keeping our fathom, not our 6 feet. I like that. Thanks, Bob, for sharing that.
Thank you.
So I know some of you have this chart, and I'm just going to do a quick scan. Okay, I'm just checking my time. We still get some good time. So this is the home waters for us. And what I'm going to do is I actually have this on a PDF. And I'm going to bring that up. And we'll come back to this chart when we start using the plotting tools. So I'm going to go ahead and click on, if I can get my mouse to work. And there we go. So hopefully you can see that just fine. And I like this because I can click it around. Now, one thing that I had to think about when
hold on, Nicholas, hold on for just a second. It looks like we have someone else, Marshall, sharing their screen accidentally. I don't know how that's happening. Let's see if Marshall, can you just close out, stop sharing your screen if you don't mind? I don't know why that's happening. Nicholas is the only co-host in this meeting. So let's see.
All I can see is the screen, Crystal, so I can't help you out.
Yes. Okay, let's see. Give us just a second there, folks. Okay, stop participant sharing. Hopefully this is gonna work. Okay, sorry about that, friends. Let's see, Nicholas, let's go back. Can you try sharing your screen again, or is it already sharing?
It's up now. Let me, actually, I've got it up. Let me,
Let's see.
I can't find my, let me close this. I'll do it this way.
Yeah,
there we go.
There we go.
Now?
Now we're back in business. Perfect. Thank you
All
so
right.
much.
So folks, you'll have to bear with me. I am a boat captain who likes to drive old boats, so modern technology is a challenge. So, all right, so here we are. We've figured out where we are. We're on the Fisher's Island charts, and we're going to look at some of the things that you can see and the details on the chart, and that'll help. Again, here's the name, here's the chart number, here's soundings in feet. You can see the longitude line, 72 degrees, 72 there. And I can't quite read that, but I'll come in a little bit. 72 degrees, 2 minutes. Degrees are broken into 60 minutes. Minutes is a measure of angle, not a measure of time. This is a compass rose, and the compass rose is how we help figure out the direction. Okay. And you might notice that you have a star, and that indicates true north. That is really where the North Pole is, up there right above the screen. And then we have an inner ring, and this inner ring is pointing off in this direction. And that looks to be, let's look a little more closely at it. That is about 14 degrees to the west. There's an era in the world, and that variation is what they call that. And this is how you compensate for that variation. So when you look at a compass, the compass would say that's north, and in real world, that would say north. And that's an adjustment that you would make when you're using a compass. We're not going to get to too much detail, but you do have to compensate for a couple of errors. It's not a big deal, but okay. But it is necessary. They make it handy. If you just use this whenever you're using your bearings, that's how it works out, okay? So let's see. We've got some other stuff here. You'll notice the yellow or the tan. That's your shoreline, your land. What about the white? Anybody know what the white is? And then we've got the blue. Okay. See if anybody figures that out. And meanwhile, I'm going to go over and come in a little bit. We'll start looking at some more detail. So here is the tan is the land, and you can see there's a hill here, there's topographical showing up. That would help you out if you're trying to figure out where you are. Look, there's a big hill, that's Bluff Point Park. And the blue is water, it's shallow water. And yeah, and white is the deeper water, okay? And I'm gonna screen in here a little bit. You can see these numbers all represent the depth, okay? In here, Brilliant would have a hard time. 4 or 5 feet, I need 9 feet, not gonna work. So I try to stay away from that area. Here, 26, 27, 28, that looks good. You can see some of these other things. You can also start to see the buoys. Before I leave the depth soundings out, we have tide here and it goes up or down about 3 feet sometimes. Does anybody know whether these depths are at high tide or low tide? Okay. You can see the buoys here.
They're saying low tide, Nicholas, is what the answer seems to be from most people.
Exactly. Yep. Because that's the minimum amount of water. Now, it's not super low tide, like we get some that go a little lower than that, but at low tide. And when you're looking at structures over your head, like bridges and stuff, they talk about what it is at high tide. So your minimum clearance, okay?
Hey, Nicholas, David, who is watching, is asking, what is the restricted area?
So the restricted area right here, it says here, it says restricted, and then says it's C note A. If you go into the borders, let's open this up a little bit. Oh, wrong way. The charts will have all this writing up in here. So you'll just have to look in here and it'll say C note A is here, and that might be note B, C, D, E, F, and so on and so forth. Okay, so that's where you can find that information. Sometimes they'll send you to another reference as well. They might send you to local notice to mariners, which is how they keep track of things that are going on. It might be something simple like they've decided to put lobster pot buoys there or something.
And David, this is I'm pretty sure this is I sent out a link to this particular PDF in the email that I just sent a few minutes ago as a reminder for the program. So you should be able to check that and you can look in more detail for yourself too.
Great.
Nicholas, we've got another question coming in from our friend Alan Schaefer. He says, does GPS tend to normalize magnetic north or actual, or do you always have to make sure you select the correct one?
GPS has the ability to do both. And the big concern is making sure you've selected whether you want it to be in magnetic, true, or true. Okay. There is another error that goes into compasses, and it's created on the boat. So you have a little chart that kind of helps you with it. And so it is a process to go through. It's something we're going to look at in the next class. We'll correct for the variation, the deviation, and translate from compass to true. So those are the terminologies that we use. Okay. I'm going to go ahead and start looking a little bit at the buoys and the channels coming in. Okay. Now, before we looked at Morgan Point, and here is Morgan Point again, and here is the channel that runs in the Mystic River. Now, before I go too far, I'm going to start all the way out at the sea buoy or the entrance buoy. Notice this is a buoy that's numbered number 1. First of all, it's a triangle, so you know it's a buoy. It's got a circle. It's floating. It has G for green, C for can. In other words, it's shaped like a soda can and has in parentheses the number 1. This is the first in the series of buoys coming up the Mystic River. There are 53 buoys on the river, all right? So if you came in, now earlier on I said that you keep your red buoys to your right and green buoys to the left. So you would come in here just like this, and then you come to the next gate, and there's a red buoy on one side, and you can see why they put it there. It's shallow there and deeper here. And then there's the green, that's the number 3, and they put that buoy there because there's a rock right next to it. And I'm going to bring that in a little bit. Oops. Right there, you can see that symbol right there is Rocky Death. And there's more rocks right there. Our area is renowned for stones and rocks and granite ledges. So that's part of the scary part. As you come into the channel, you might notice that these are fairly small triangular floating buoys. This is GC, this is the red one, and N stands for none because it's got a pointed top. So red, you run right down, you keep red right returning, keep all your red buoys to your right, so on and so forth. And that keeps you off of Whale Rock and so on and so forth. This one here, you might notice, is a little bit different than the other buoys in the sense that it has a magenta halo right here. That is a lighted buoy. And if you look right next to it, there is a code, okay? And first of all, it says red, so you know that. It's got the number, that's a number 4 buoy. And it says FLR4S. FL stands for flashing, red, 4 seconds. So this is the first lighted buoy in the series, and it's important because they really want to make sure you don't hit Whale Rock. Every 4 seconds, 4S, a red light flashes, okay? And then you proceed down the channel, and the next one is No Ank Light, and this is actually a lighthouse. They never say lighthouse on the chart. It's kind of goofy, but you can tell a couple of different ways. One is you see this exclamation point. That basically means that it's stuck in the ground. So you would have small poles stuck in the ground or lighthouses stuck in the ground. You can tell by the code right here. In this case, it says quick green 22 feet. And what that says is a green quick means once a second, green, and the structure is 22 feet tall. So it gives you an idea, it's a little bit bigger than just a buoy. 8M means you can see it in good conditions for 8 miles, and it's number 5. It's got number 5 on some boards mounted right here. We call this a spindle. And this is actually a tricky part of the river because you can see how shallow it is outside the channel. And when you're bringing a big boat in and around the corner here, that can be challenging. And many a schooner and large vessel has ended up in the mud up in here. And then you can see it just runs along the shoreline. These are the red buoys, each one increasing in red the whole way down. And that channel just proceeds all the way down the river, okay, until you get up towards our house and so on and so forth. Here's No Ank, so on and so forth. Here you can see the railroad tracks coming through. There's a bridge right here, and that's a fixed bridge with a horizontal clearance, which means it's 49 feet wide, and it's only 5 feet tall at high tide. So that's not a great place to bring a sailboat. But if you're in a rowing boat or a skiff, you'd probably be fine. You have another structure here. I can't find the information on it, but this is a shallow body of water, okay? And I'm gonna come up and go a little bit further, and you can see the railroad tracks go over the water. Here's another bridge. That's a swing bridge, which means it pivots and twists out of the way. You get 90 feet wide and 8 feet high when the bridge is closed. And that, of course, is at low tide. So you might not be able to bring a sailboat, but you can do some of that with a powerboat. And I'm not going to go into too much more detail other than start pointing at some of the landmarks on shore. This is a church spire. And we can use those to help us when we start doing the navigation stuff, okay? Let's see, we're looking at about 12:15. So am I, Chris, doing all right on time? I want to get into the plotting tools as well.
Yeah, Nicholas, you're fine. Go ahead and get into the plotting tools if you want.
Okay. Let me just go over a couple of other things real quickly. I'm going to bring this out. I'm going to talk about, let me check my notes. Scale, chart number 1, info, we did that, depth. We're going to talk about direction and distance, okay? The way we figure out direction, we may have already indicated a little bit, is by using the compass rose, okay? We talked about that briefly, okay? And the compass rose is going to give us the directions. And since we are working with a compass, we're going to go ahead and use the inner rose, okay? Since I don't have a electronic compass, which will compensate, or a GPS compass, or they call them fluxgate compasses is another word. And they can, and do very often do, give you actually true north, which takes some of the guesswork out of it. But we have that, the compass rose. Now in the compass rose, we've got a couple of things. You'll notice that this is 0. I'm going to see if I can make it one bigger. There we go. 0, 90 degrees is due east, 270 is due west, and 180 is due south. Okay, and this map, like most, is oriented north. Right here, it will tell you what the variation is. So that's location on Earth. It's 14 degrees west. And that was in, I can't read it, but that was when it was. It changes every year. It changes about 3 minutes every year. So every year, this increases and goes that way, 3 minutes. And 3 minutes isn't a lot, but it certainly can add up after a while, okay? I'm going to skim out a little bit, and we'll start looking at our latitude and longitude scales. And I'm hoping that, yeah, here we go. When you're looking at distances on the chart, okay, you can do it one of two ways. One is you can find the scale. And like most charts or maps, there's a scale there. This is nautical miles, which is a little bit longer than a land mile. And there is 0, there is a quarter, or excuse me, a half, and that's 1. So that represents 1 nautical mile, okay? So these increments are a half mile. They've taken this and broken it down into even less, 1, 2, 3, 4, 5. So those would be 0.5, 0.10, because it's a half mile. And so you can, when you're looking at the chart, and we'll do that in a minute, and then they have a yard scale underneath, okay? Now, I don't know if this chart is a good one for that. Yeah.
Hey, Nicholas, if you don't mind, while you're doing that, a few questions are coming in.
Sure.
I'll start with the last one that came in from Pierre. What are the inner graduations of the compass rose?
Right in here?
I think so. I think that's
yeah,
what.
So those are the same things, except for this would be 0, this is 90, this is 180 due south, and this is 270 due west. Hopefully that answers. And then because we have to be precise if we're going long distance, this is 270 and this is 280. So that represents 10 degrees of change. Okay, the whole compass is 360 degrees. Okay.
And our friend Bob, oh, so Pierre is actually asking the inner ones, the third set of graduations. And our friend Bob is saying the inner is the magnetic, the outer is true.
Yeah, this ring here is the inner, and that is the magnetic. You can see it says magnetic there. And the outer one that's connected to the star is true north.
Okay. And then our friend Chip also just chiming in, the restricted area also provides the spot in the CFR where the Coast Guard has the regs that establishes the no-go area.
Oh, nice.
So, and then one other question from David, he's asking, have you ever heard of Nathaniel Bowditch?
Yes. Nathaniel Bowditch is a legend in our business. He was able to take some in the old days, everybody had their own version of the charts, and particularly when you're crossing oceans and you don't have landmarks, you have to use the celestial bodies, the sun, the moon, planets, and so on and so forth, as your landmarks. And Bowditch was just an amazing navigator who took some tables that were already written and refined them and corrected them. And he created American Practical Navigator, which is a Bible for you doing celestial navigation and navigation in general. And one of his claims to fame, besides rewriting America Practical Navigators, is he actually sailed into Salem, Massachusetts through the Rocky Ledges in dense shutout fog because he was so good about navigating without any visuals or anything like that. And we'll talk a little bit more about how you would navigate pre-GPS days, but it was a feat that most people would not have tried. They would have waited outside till the fog went away. He didn't. He sailed into the harbor. He didn't crash. So therefore, he became a legend in addition to some of the. But the reality is he's one of the best navigators that ever lived. So, all right. So we were looking at, any more questions on the compass rose? You know, we'll go into detail on that a little bit more next class when we start to get into that. Now this chart here, you'll notice is, this isn't going to work for me. So I'm going to come out with this. And we're going to start looking at, how are we doing for time? I'm going to start looking at tools here in a second.
Yeah, so Nicholas, we're at 12:17. So you want me to switch you back over to your other camera?
Yeah. When are we ending? 12:30? Is that right?
Yeah, we can end around 12:30.
Okay. All right. Yeah. Why don't you go ahead and switch me back to my chart, and
okay,
I'll bring
so
that
just
with some of the tools.
Okay, so Nicholas, just stop your screen share, and I'll be able to highlight your other camera.
And we can. I can't get it to work on this chart. We can always go back to some of that other stuff if we need to, you know, so on and so forth. So what I was trying to point out is, as I pointed out the latitude scale on the chart, and I want to talk about latitude and longitude. And unfortunately, this chart doesn't grow into the detail that I would like. So I'm going to quickly bring back another chart here. And you can see on that side here, this just makes it a lot easier. Oops, slow down, Nicholas. All right. So does anybody know the difference between latitude and longitude? Okay. Right now we're looking at the longitude scale, which is the horizontal way. And now I'm looking at the latitude scale going up and down. The way I remember it is it looks like a ladder. Latitude is east, west, longitude, north, south. Yes, perfect. Yep. Exactly. Okay. So we have our latitude scale here. Okay. And it's broken down. And the reason I chose this is that on a medium scale chart, it's much easier to see. So we have right here 40 degrees. I'll bring this over. 40 degrees, 20 minutes. And then if we come down a little bit, we come to 41 degrees, 15 minutes. And then we come to 41 degrees and 10 minutes. Each one of these is 1 minute of latitude. Okay? So this is 41 degrees 10, 41 11, 41 12, so on and so forth. Okay? Then they break each one of these minutes even more so. In most charts, most modern charts, they put 10, so it's days 10, so take 10 pieces. So this is 41 degrees, 10 minutes, 10.1, 10.2, so on and so forth, okay? And that makes it easy. The chart that we're looking at, they break this up differently. They break it into seconds, which instead of being 0.10 is base 6. So it gets to be a little tricky and confusing. And rather than getting into converting right now, we'll do that later, okay? But one thing that latitude offers us is this is 41 degrees north, okay? and that means that we are north of the equator, okay? If there's a 41 degrees south as well. If you look at your longitude scale, the longitude scale, of course, goes horizontally across and has the same breakdowns. One thing you'll notice is, I'm going to use, these are dividers and they measure a distance, is you'll notice that my longitude scale, the units of measure are different than the latitude scale, okay? The latitude scales stay the same throughout the whole thing, and I'll show you on something to help you remember that. But right here, we have 72 degrees, and notice that this increases as we go to the west, 72 degrees, 5 minutes, 72 degrees, 10 minutes. That's because we're moving west from the main, what they call the Greenwich Meridian, where 0 degrees longitude is, and that's in Greenwich, England. So right now we are west of England, so this is going to increase. If we go to the other side of England, it would increase in the opposite direction. So I have a lot of people who get caught up and they start increasing this way. So just be careful of that when you're doing your navigation, okay? The other thing about the latitude scale is this is 1 minute of latitude, and the reason we use nautical miles is that 1 minute of latitude equals 1 nautical mile. So you can take a measurement from here using your dividers, okay? So
hey, Nicholas,
instance,
can you,
yeah?
Nicholas, can you just focus the screen for, yeah. And actually, we're getting a question in from Chip while you're doing that.
Okay.
Nicholas, for latitude north of the equator, is it positive number and south is negative? So latitude 30, south is written negative 30, is what he's asking?
No, traditionally what you do is this would be 41 degrees, 20 minutes north. So whenever you write latitude and longitude, it's a good habit to get into to put north latitude and east or west longitude.
Thank you.
On our small little scale, it's easy to forget that, there are others. So we just say, oh, I'm at 4120. Technically speaking, and traditionally, we would say, I'm at 41 degrees, 20 minutes north. So it's north and south, east and west versus positive or negative. Okay. So if I take my dividers and I want to know the distance, let's say, let's go from this point of land, Black Point, to the light that is on Bartlett Reef, okay? It's that would be our distance. So if I come over here to my latitude scale, which is a lot easier to get to than the other scale, I can go, I put this at 15, so I have 1, 2, 3, and then I got 2 little ticks, 3.2 miles. So that's how you would use a dividers for figuring out distance. Another technique, if it was more than the spread of your dividers, is to take it and put a pre-measured distance. Like I'll put 5 miles in here, and then I can figure that from Black Point there's 5. Oh wait, let me get it on screen. Where are we? 5, and then I can flip it without changing this point. 10, 15, 20. So I can actually tick those off. I'm going to do that on a smaller scale. I'm going to set this for 2 miles and make it a little easier to see. So from Black Point it would be 2, 4, 6. 6 miles and a little bit, and this is the New London Channel. I'm going to see what that little bit is. 6 plus 1, 2, 3, 4, about 6.4 miles from Black Point to the entrance buoys in New London Harbor. Okay, so those are dividers, and that's probably the easiest way because you can change it. There's a number of different types. There's, these are called one-handed dividers, and the beauty with these is you can just grab it with one hand and open and shut it. This one you have to do that. And then there's others, there's fancy modern ones. You can use a compass, like the old compasses for drawing circles. That'll work just fine for you. But basically you want something that isn't going to move when you shift around. So those are called dividers. Okay. and very important tool. So that's basically how we figure out distance. And using the latitude, of course, saves us from having to go all the way to the scale, okay? The other thing that we're going to use are known as parallel rules. And the parallel rules allow, as the name implies, you have two parallel edges, okay? If I open them up, they still are parallel to each other, okay? You can use this to, let's say you wanted to figure out how to go from Black Point to Bartlett Light, okay? What I would do is I'd come up and I would line this. I'm going to do it on this side so you can see how we walk the parallel rules. This is the course that I'd like to steer. I'll move this down a little bit. This represents the course that I would like to steer, okay? And I have to remember that I'm going this way, okay? So now what I'm going to do is I'm going to hold this one nice and tight, and I'm going to move this one down towards the compass rose. I didn't quite make it that time. Where I'm headed is the exact center. There's a little cross right here. So now I'm going to stop, and I don't want to change this because I'm going to change my course, all right? So I set this back up the way we had it, hold this, move this down. Oh, I'm going to move this one up instead, okay? Without changing that, I'm going to come right up on here, and I got it going through the center, and then I'm going to come and I'm going to read what it crosses here, all right? Now that's a little tricky to see, I know. I'm going to see if I can come in. Oh, I can't come in anymore here. Let me try this instead. Of course, I wouldn't pick something easy. It looks to be about, here's 120, so 119, 18, 17, 117, and since I'm using the inner rig, that is a magnetic course, so that would be the compass course that I would steer. If I went out here to the outer ring, it would be 14 degrees different. So we're not gonna do that. We'll use the inner ring. So what that says, if I leave Black Point and I steer 117 degrees, I will be moving in this direction, and hopefully I will find this, this light, which would be handy because this light is trying to keep me from getting into the rocky depth that is here, okay? So that's one way that we use that to figure out our course. Now, of course, in order to do that, I have to know where I am. And there's a lot of ways of figuring out where you are. One is by using the buoys, or in this case, the lighthouse. This is more of a tower than a lighthouse. But if you're here and I was sailing by here, I would come by. When I was close, I would put a position down so I knew where I was when I was there. Traditionally, I would put a dot, which says where we were, and then I'd put a circle, which means a visual fix. And that way, I have a baseline for where I'm starting from. So once I reach Bartlett Right, I could go ahead and kind of go off and run my course along up into Fisher's Island Sound and the Mystic River, you know?
Hey, Nicholas.
Yeah.
We're getting a question. When should you use magnetic instead of true north on the compass?
Your compass is going to read magnetic. So if you're using a compass to steer,
or on the compass ring, I think is.
Yeah.
What?
So you would use the inner ring if you're trying to find out what your compass is reading. Sorry, so you want to use this. So if you use your compass for steering and it's a magnetic compass, you would want to make sure that it's your course is in magnetic. In other words, it lines up with this ring. If the tricky part is a lot of times some other instruments, and I'll get into that in a minute, you can only get true. So you have to do a conversion. You have to add or subtract that 14 degrees. Okay. If you're using a compass to get bearings, and I'm going to go into that in a minute, you would use your inner ring. And if you're using it to steer by, you need to figure out what this one is. You need to have it converted to magnetic. Okay. Because I hope that answers your question. And that does lead me to another set of tools. And these are triangles. And this is why you need to convert. These triangles are great because I can move this around and move my angles around. If I do my same example here, okay, going from Black Point to the reef, or excuse me, that to the reef, I could just slide this. I could do it two ways. One is I could slide this down to the center, and there's my answer, a little bit about 117. But also these have gradations on the sides. So for instance, I can line this up with a vertical plane, and then I can just adjust it. That's 090, true. Okay, and this is why we have to be able to convert. So if I go this way, that's 090 due east. And if I go that way, it's 270. But let's say I don't want to go 090. I can rotate this a little bit and line this up to 070. I line that up right there on the vertical line, and I line this up down on the bottom to 070. And so this line now represents 070 in one direction and 260 in the other. Where this is handy is when you don't have, you have a big chart and you don't have a compass rose very close. The problem with parallel rules is as you move them along, it's very easy to shift them by accident. So there's a couple of conversions. I think it'll make more sense when we start plotting courses next trip, and we'll go over converting back and forth. And there's a great moniker, can dead men vote twice at elections? And we'll explain what that means, okay? So anyway, so that's how you would do that to figure out your course. To figure out where you are when you're not right next to a lighthouse or a buoy, we can take our compass and use bearings from them. And a bearing is basically a compass direction. You can use, you can look at a big compass like this, right? This is actually a small compass, but if I sit there and I look in there and I put what I'm looking at right above it, I can get a direction to an object. This is another one. This is what's known as a hand bearing compass, okay? And I can look through this little sight glass right here, and I can take the object and make it appear right on top of that, and then that'll give me the bearing or the compass course to get to that location. Here's another one. We call this a hockey puck. And again, you just look right in here. I don't know if I might be able to get a view there. Can you see the numbers?
Yeah, just barely, yeah.
Just barely.
285, yeah.
Yeah, so what you would do is you would aim it at something and then put that object right here, and that would tell you the bearing to that object. The way that we use that, of course, I don't have a pencil. Every good navigator has a pencil. Is let's say we came out here and we're using the Bartlett Reef Light, okay? I'm somewhere out here and I get my handy dandy compass up and I get a bearing on that lighthouse, okay? Then I come down and I'm gonna make this simple. Let's say that bearing is, I'm gonna make it real simple. Let's say that bearing is 180. Now, since I took it with a compass, that's 180 magnetic. I'm going to come here. I'm going to line up my parallel rules with 180. Okay, I'm using, because it's a compass, I'm using the inner ring. And then I'm going to slide this over without changing it, like I just did. And I'm going to put that right through the dot there. And I'm going to take my pencil. I'm going to draw a line. We know that we are on that line. We don't know where on that line we are, but we know we're on that line. That's called the line of position, okay? So that doesn't do us much good unless you want to know where you were on the line. Any ideas on how you would figure out where on that line you were? Yes, you take another bearing.
Needing two more bearings, draw another line, intersecting bearing.
Exactly, exactly. So basically you find another object that's identifiable in the chart. We've got the buoy right here, the Morse Alpha buoy. We could probably use Black Point as well. And we would just have those, have another line going this way and another line from something else. And that gives you, and it's very interesting you said two bearings, because most people would go, oh yeah, you need two lines to cross, and that gives you a position. And yes, it does. What is the third bearing for?
Not getting anything so far.
I know you guys got it.
Verification.
Exactly. Yeah.
Limit the error. Yeah.
If you put the 3 lines together and they don't meet, at least come close to it, you're going to look at having a bad day, or one of those bearings is wrong. And so let's say we have a bearing on a lighthouse here, and we have a buoy over here. We get a bearing like that. And so that would say that we're there, okay? And then we took one here, and you would expect that it would line up like that, right? All 3 would cross perfectly. They very rarely do. The reason is you're moving and nobody can take a bearing that well. Usually what you end up with is what they call a cocked hat, a triangle. In theory, you were somewhere in that triangle. Now, if the 3rd bearing comes off and it's like gigantic, that triangle's too big, you might not have gotten the right buoy, you might not have gotten the right numbers. So it's a good check to make sure you're not running into problems. But you got a nice cross. I put up my dot right there. I put a circle around it because it's visual, and I put a time, 13:30. And now you've got something to work from, and now you can do your course and set that out there. And we'll get into that in a little bit more detail next week. Okay.
So Nicholas, I did just want to let you know it is 12:37. If you have any final thoughts for this week.
Yes, and we must be on the same page because that was the last thing I wanted to teach. So that is again just a brief and quick overview. There was one thing I forgot, and I've got to bring it up because I made it.
I'm glad you showed that.
Yeah, I couldn't resist. And let me get the right one. This is supposed to show you latitude and longitude, and you may or may not have already figured out. I mentioned that the latitude scales are all the same. No matter where you are in the globe, it's 1 minute equals 1 mile. The longitude scale does not remain constant. I forgot to tell you that throughout. The closer you get to the equator, the wider it is. And my model right here will show you. Well, there we go. Anyway, they call these parallels of latitude for a reason. They're all parallel and they're the same distance. That's the constant. Longitude gets wider as you get to the equator and narrow as you get to the pole. So you can't use them for distance. And the reason I say that is everybody does that. All right. All right. That's all I got for this right now. I guess we're open to questions.
Yeah, thanks so much, Nicholas. And it's just for those out there who want to join again next week, it is looking like this program next week we're probably going to do on Tuesday afternoon. So make sure that you're on my email list. Again, I'm going to put my email address in the bottom in the chat box. Oops, I just sent it to someone privately. Hold on, sorry about that. Let me send it to everyone. And if you want to be added, just send me an email. And Nicholas, we're getting so many thank yous rolling in, including someone, David, who sailed with you on Brilliant a few years ago. Nice to see you again. So many thank yous, so much good feedback. So Nicholas, this has been a real treat. Cannot wait for next week to learn more. And thank you, everyone. Have a great rest of your day. Tomorrow is Thursday. Our public program for tomorrow is tomorrow afternoon at 3:30. Our Senior Curator of Collections, Fred Calabretta, is going to be doing a presentation about whaling in the movies. So I'm sure that is going to be really fun to watch. So join us for that tomorrow afternoon, and hope to see you all again soon. Thanks, everyone. And thanks so much, Nicholas.
Thank you, Crystal. Thank you, everybody. We'll see you next week.
Bye-bye.